Before the first spark, before the first breath of space or the first tremor of time, there was a silence so complete it could not even hear itself, a silence without a stage, a void without a name. And yet, from this absence, from this impossible emptiness, everything we know would someday rise. But how can nothing give rise to anything at all? How can a force defined by non-existence become the greatest architect of existence? The question hangs there, weightless, defiant, unsettling, because if nothing truly had no power, the universe should never have happened. And yet, here we are. Stars burn, galaxies dance, minds awaken and ask impossible questions, all shaped by a beginning that should not have begun. But the paradox goes deeper. The more we study the cosmos, the more nothingness refuses to stay empty. It bends space, seeds creation, defines the limits of what we can know. It hides behind every beginning. It waits at every edge, and we're left wondering, if nothing has no power, like why does it keep winning? Before existence, before direction, before the faintest murmur of possibility, there was a silence so absolute it could not even be called silence. Silence needs space to rest in. It needs time to stretch across. In the realm before existence, there was neither, no canvas, no stage, no darkness, because darkness needs a place to be dark in. No emptiness, because emptiness requires boundaries. What existed was a condition so foreign to the human mind that our language fractures the moment we approach it. We call it nothing. But even that word is too heavy, too full, too shaped by the world we live in. Because the instant you imagine nothing, you have already imagined something. A void, a blank room, a black expanse. You have given shape to shapelessness. You have betrayed the very idea you are trying to grasp. And so the journey begins with a contradiction. To imagine true nothingness, you must erase the imagination doing the imagining. Yet we try. We always try. Humans have stared into the abyss of non-being for thousands of years, attempting to draw meaning from what should resist all meaning. The ancient philosophers spoke of it with trembling hands. Some called it the primeval chaos, not because it was chaotic, but because they needed a word, any word, to gesture at the place where words break. Others believed the universe was eternal, not because they had proof, but because the alternative, a beginning emerging from nothing, felt too impossible to accept. How could something arise from what is not? How could being spring from non-being? The paradox taunted them. It taunts us still. We are creatures born inside existence, shaped by time, sculpted by laws, confined to a world where things follow from other things. Every cause has an effect. Every effect has a cause. Every thought sits in a brain. Every star clings to gravity. Every particle dances to rules written long before life began. We do not know how to think outside that structure. We do not know how to breathe in a place where breath has no meaning. And so when we try to picture nothingness, real, absolute nothingness, our minds slip. They fill the silence with shadows. They paint the void with memory. They mistake absence for emptiness and emptiness for calm. But true, nothing is not calm. It is not dark. It is not still. It is not anything. It cannot be, even as a thought. But still, we press on. The scientists of today fare no better, though they use different words and louder equations. Ask a physicist what came before the universe, and many will pause, smile, and say, the question is flawed. Before has no meaning when time itself has not yet been born. Ask them what existed outside the early cosmic expansion, and they remind you, outside only exists when space exists. Ask them what the universe emerged from, and they answer with a quiet shrug. Because the closest modern physics ever gets to nothing isn't nothing at all. The quantum vacuum, as empty as it seems, teems with virtual particles flickering in and out of existence. Fluctuations, fields, potential, all of it buzzing just beneath the surface. It is not nothing. It is a canvas already primed with possibility, a stage decorated with invisible actors, a silence interrupted by whispers too faint for human ears. But true nothingness would have none of that. No canvas, no stage, no whispers. In the deepest philosophical sense, absolute nothing is the absence not just of things, but of the capacity for things. No laws to govern, no field to fluctuate, no space in which to tremble, no time in which to appear. A realm where even possibility collapses. A realm where the very concept of a realm dissolves. Try to imagine it again. Feel your thoughts reach for form and then let the form dissolve. Try to imagine the absence of dimension. Try to imagine a place where place has not yet been invented. You may last a moment, and then a familiar sensation crawls in. Disorientation, cognitive vertigo, the uneasy feeling that you're standing at the edge of understanding and the ground beneath you has quietly disappeared. Because to truly picture nothing, you must silence the mind that pictures. But the mind refuses. It looks for edges, patterns, shapes. And so nothingness becomes the first great opponent in our story. Undefeated, untouchable, a mystery that humbles every intelligence that approaches it. And yet, it is the first chapter of everything. This is the irony that binds the universe to its own impossible beginning. The very thing that should not exist, the very condition that defies all description, becomes the seedbed for all description. The place where no laws reign becomes the birthplace of laws that endure for billions of years. The realm where nothing can happen becomes the place where the greatest event of all time occurs. But what does it mean for something to happen when there is no time for happening? What does it mean for a universe to erupt from nothing if nothing does not exist to erupt from? The contradiction deepens the more we study it. Every theory, from quantum cosmology to metaphysics, returns to the same cliff edge. Either the universe came from something, or it came from nothing, and both options feel impossible. Something cannot arise from nothing, and something cannot be eternal without raising more questions than it answers. We are trapped between two infinities of confusion. And yet in that confusion, a strange kind of beauty emerges, because the fact that we can ask these questions at all means the universe produced beings capable of contemplating their own impossible origin. Out of nothing came curiosity. Out of nothing came wonder. Out of nothing came the very urge to know why anything exists. But nothingness is patient. It does not answer. It simply waits at the boundary where our understanding evaporates. It stands there like a silent guardian, reminding us of the limits of thought. Ancient mystics believed that nothingness was not a void, but a womb. Not the absence of existence, but the potential for existence. A blank that holds all shapes, a question waiting for its own answer. Others believed nothingness was the purest expression of truth, a truth beyond being, a truth that does not need to exist in order to be real. And in a strange way, modern philosophy circles back to the same place, because when we attempt to describe absolute nothing, We are forced to confront the fact that our universe is fundamentally strange, not because it is full of stars and gravity and life, but because it is here at all. Every cosmic truth begins with a failure of imagination. Every scientific breakthrough begins with a question that should not make sense. And at the root of all roots lies the one question that breaks every rule. How does something emerge from what cannot exist? How does being claw its way out of non-being? Some theories claim spontaneous creation. Some propose quantum origins. Some invoke multiverses bubbling endlessly. But all of them assume one thing, that the fabric of reality has some underlying structure. True nothingness has no such fabric. And yet something happened. A shift, a rupture, a birth. A moment so transformative it rewrote the fate of all future galaxies. But what triggered that moment? What moved in a place where motion had no meaning? What changed in a realm where change was impossible? These questions haunt us because they expose the deepest contradiction of all. Nothingness is not passive, it is not neutral, it is not dead. In the story of existence, nothing is the first force we encounter, and the last one we understand. When philosophers speak of nothingness, they often describe it as a mirror that reflects nothing back. But perhaps it is more like a horizon. No matter how far you walk toward it, it stays just ahead, always unreachable, always receding. Try to define it, and it slips into paradox. Try to grasp it, and it disappears through your fingers. It is a mystery that asserts its dominance by refusing to be solved. And yet it shapes every answer we search for, because every question about beginnings is a question about nothing. And so the journey continues through silence, through confusion, through the vertigo of imagining what cannot be imagined. We walk deeper into the paradox, knowing we cannot win, but needing to understand. Because at the end of this path lies the most unsettling possibility of all. Absolute nothing might be the most powerful condition imaginable, precisely because it cannot be imagined. It is a force that does not act, yet defines everything that follows. A character that never appears, yet shapes every scene. A truth that never reveals itself, yet frames the entire story of reality. But the contradiction only grows sharper, heavier, more demanding. If nothing truly existed, pure, absolute, undefeated nothing, why couldn't it stay that way? Nothing did not fall the way a stone falls, or the way a star collapses into a black hole. It fell the way silence breaks when a single thought appears in a mind that wished to stay empty, a fracture without location, a tremor without time, a disturbance so small it had no size, yet so consequential it would rewrite the destiny of everything that would ever exist. Before this moment, if moment can even be used, there was only the quiet tension of absolute nothingness. No fields, no particles, no laws, no order, no direction for change, no possibility for possibility, but nothingness in its purity hid a flaw so subtle that only a universe could expose it. Because even in the deepest void, instability waits like a spark beneath ash. At the threshold of existence, reality hovered at something physicists call the Planck scale, a realm so small, so brief, so violently unknowable that our mathematics shatters when it approaches the boundary. Planck length, Planck temperature, Planck time. Concepts we use not because they clarify, but because they signal that clarity has abandoned us. This early universe was not a universe at all. It was a roiling quantum storm where the very fabric of space-time had not yet learned how to be fabric, where gravity tangled itself with all other forces into a single, unreadable knot, where every attempt to describe what was happening collapses into metaphor because no human has ever witnessed a reality with no rules. But if nothing had no rules, then nothing had nothing preventing it from becoming something. In that contradiction lies the first fracture, the realization that the perfect void may never have been stable. Some theories suggest that absolute nothingness cannot remain nothingness, that it is inherently volatile, that the absence of all things is not a calm, peaceful state, but a precarious equilibrium, always on the verge of unraveling. True nothingness, in a strange and haunting way, is self-defeating. The moment it exists, even conceptually, it carries within it the tension of possibility. And possibility is a kind of pressure, a pressure that must eventually release. So the void trembled, not in space because space did not exist, not in time because time had not yet begun to flow. The tremble itself created the conditions it needed, a self-causing moment, a seed erupting before there was soil, a flicker of uncertainty that expanded faster than uncertainty could be defined. In physics, we call these flickers quantum fluctuations, tiny spontaneous appearances and disappearances of energy that violate stillness. They are the universe's most ancient rebellion. Even now, in the most perfect vacuum humans can build, these fluctuations whisper beneath the threshold of matter. But at the dawn of creation, they were not gentle whispers. They were storms, storms made of raw probability tearing at the edges of non-being. Imagine a silence so complete that even silence feels too loud. Now imagine a single infinitesimal disturbance breaking that silence, not from the outside, but from within the silence itself. It does not sound like an explosion. It does not ignite like fire. Instead, it unfolds like inevitability. The first spark was not a violent burst, but a failure. The failure of nothing to remain nothing. A surrender disguised as creation. A collapse of impossibility into existence. Planck time, the earliest age of the universe, lasted only 10·43 seconds. A number so small it mocks comprehension. In that unimaginably brief sliver of becoming, the universe behaved like a fever dream of quantum chaos. Temperatures soared beyond anything numbers can meaningfully express. Energy densities reached levels where space curled upon itself and uncurled again. Matter did not yet exist, but the ingredients of matter danced in potential. Forces flickered in and out, undecided on their identities. Gravity and the other forces were still fused, as though the universe had not yet remembered how to separate its own fundamental rules. For us, this era is the closest science ever gets to the origin, a place where our equations cease to describe and instead begin to plead, because at the root of every model lies a truth that is both unsettling and profound. The universe may have begun not as an event, but as a breakdown. Nothing could not maintain its perfect emptiness, and in its collapse, time was born. Space unfurled. Energy spilled into existence. The void cracked, and through that crack came everything. This first spark was not the Big Bang as we often imagine it. It was smaller, softer, stranger, not a burst of matter into space, but the birth of space itself. A cosmic heartbeat where the heart had to invent its own pulse, a moment where fluctuations surged until they could no longer cancel themselves out. One fluctuation survived. One imbalance refused to vanish. And that single refusal became the foundation of reality. The stillness of nothing had been interrupted. The interruption became irreversible, but the paradox deepens. If nothing truly lacked structure, how could it destabilize? How could instability exist in a place where existence does not exist? This is the riddle at the core of Planck time. The recognition that nothingness, to be nothingness, must be unable to hold itself together. That in the absence of rules, the first rule emerges: instability reigns. This is the first spark, the birth of differentiation. The moment when the universe stopped being an impossibility and became a question. As the Planck era raged on, the universe expanded at speeds that defy imagination, not through space but as space. Volumes unfolded out of mathematical absurdity. Distances increased without anything moving. Waves of probability surged outward before light could even form. The universe did not grow into a vast cosmos. It exploded into being from the tension that preceded it. A tension born from nothing's inability to stay perfectly empty. At this scale, time was not yet time. It was a feverish sequence of becoming and unbecoming. Events happen not in order, but in turbulence. Cause and effect twisted into loops. Particles emerged halfway formed, then dissolved, then reappeared as something else. Possibility outweighed reality, and reality had to fight for its right to crystallize. This fight, this cosmic struggle, was the first heartbeat of everything that would follow. The fall of nothing was not gentle. It was not peaceful. It was not calm. It was a collapse into potential, a storm without a sky, a furnace without flame, a birth without a womb. And yet within this chaos, something miraculous occurred. Order began to negotiate with disorder. Patterns flickered within the noise. Symmetries formed and fractured. Laws emerged tentatively, like animals testing the air before stepping out of the dark. Gravity loosened its identity from the other forces. Energy condensed into the first proto-structures of reality. The universe began to remember itself. But even as these rules formed, the ghost of nothingness lingered at the edges. It had not vanished. It had merely failed to dominate. It remained woven into the fabric of the newborn cosmos, the background instability that allows particles to flicker, the vacuum energy that pushes galaxies apart, the quantum uncertainty that shapes every atom. Nothing had not disappeared. It had transformed. It had become a silent partner to existence, forever trying to reclaim what it lost, forever fueling the fluctuations that make the universe dynamic. This is the cosmic irony. In falling, nothing gave rise to everything. In failing, it succeeded. Its collapse became creation. Its instability became structure. Its fleeting spark became the stage on which stars, planets, life, questions, and consciousness would someday unfold. And the universe in its infancy carried this contradiction like a hidden scar, a reminder that it was born from a flaw, not a plan. As the Planck era drew toward its end, the universe cooled just enough for the turbulence to soften, not into calm, but into coherence. Space-time smoothed, energy diluted. The laws of physics settled into their familiar forms. And with that settling came the first real possibility of a universe that could survive its own birth. Yet one mystery remained unresolved, lingering like a whisper behind every unfolding moment. If nothing was so unstable, if its collapse was so inevitable, then what force emerged to replace it? What took hold of the cosmos once nothing let go? What fundamental power stepped into the void to shape the universe after nothing failed to hold itself together? Because something must have taken its place. And so the act ends with the question that drives us deeper into the story. If nothing cannot hold itself together, what powerful force takes its place? The fall of nothing did not end in a whisper. It ended in a detonation of becoming, a transformation so abrupt, so unstoppable, so violently absolute that the word explosion feels timid beside it. What followed the collapse of the void was inflation, the most extreme growth spurt the universe would ever experience. A trillionth of a second during which the cosmos expanded faster than light could chase it, faster than information could keep up, faster than meaning could form. It was not merely rapid, it was ferocious, a runaway consequence of nothing breaking and everything rushing in to occupy the emptiness left behind. In those first breaths of existence, the universe was unimaginably small, smaller than a proton, smaller than anything we can name, a trembling patch of space-time newly liberated from the instability of nothingness. But liberation came with a cost: chaos, pressure, and a kind of existential recoil. When the void failed, it didn't collapse gently into a new reality. It recoiled outward, unleashing energy so dense it refused containment. Inflation began not as an event, but as an inevitable consequence. The universe did not choose to expand. It was compelled, swept up in a surge that had only one direction: outward. Imagine a balloon that inflates not over seconds or minutes, but instantly, its surface doubling again and again faster than thought itself. One moment, the universe is a quantum speck. The next, it is a storm of stretching geometry, tearing itself apart and rebuilding itself simultaneously. Distances grow without anything moving. Space multiplies without asking permission. The very fabric of reality strains under the velocity of its own birth. This is not expansion as we know it. This is creation, outrunning the possibility of collapse. During inflation, every tiny wrinkle of space-time stretched into cosmic vastness. Tiny imperfections, smaller than particles, became the seeds of galaxies. Quantum fluctuations, once ephemeral and insignificant, became the scaffolding for cosmic structure. The universe was smooth in itself, ironing out chaos with overwhelming speed, leaving behind a nearly perfect uniformity punctuated by the faintest imprints of ancient turbulence. These imprints, billions of years later, would form the cosmic web, the vast network of galaxies strung across the heavens like filaments of frozen lightning. But in this early age, there were no galaxies, no stars, no atoms, no stability, only motion, only acceleration, only the violent surge of space unfolding at a rate that defies imagination. The numbers are monstrous. In less time than it takes light to travel the width of an atom, the universe expanded by a factor so huge that even writing it down feels like an insult to the truth. It grew from microscopic to cosmic, from quantum to astronomical, from formless to structured. Inflation was not simply fast. It was the fastest anything in the history of existence has ever occurred. And at the center of this storm was the lingering echo of nothingness, stretched thin, diluted, and overwhelmed by the force that replaced it. Yet paradox thrives even in the heart of expansion. For while the universe grew beyond comprehension, nothing inside it traveled faster than light. Instead, space itself expanded and pulling everything with it. Relativity did not break. It simply bowed to a deeper rule. Space can do what objects cannot, It can grow. It can accelerate. It can stretch distances faster than photons can cross them. And in this freedom, inflation flourished. It is difficult for the human mind to feel this scale. We can speak of trillions, but they remain abstractions. We can imagine vastness, but vastness always has a horizon. Inflation has no horizon. It creates the horizon. It defines the boundary of what we can see, not because the universe stops beyond it, but because inflation swept distant regions away faster than their light can ever reach us. In this way, it left us enclosed in a visible bubble, a cosmic island, drifting in a sea of unknowable space, a boundary, not of walls, but of time itself. And still the expansion continued. Energy drove the inflationary surge with terrifying intensity. Temperature soared, yet temperature had no true meaning when matter had not yet formed. Pressure skyrocketed, yet pressure was just a mathematical ghost in a world without atoms. Everything existed as potential, condensed into a field so powerful it bent reality into hyper-acceleration. This field, the hypothetical inflaton, acted like a spring wound too tightly. Once released, it unwound with catastrophic speed, unleashing the ultimate act of cosmic overcorrection. What began as the instability of nothing became the violence of everything. The silence that preceded creation became a storm so loud it drowned its own sound before sound could exist. Inflation was chaos at maximum volume, a universe screaming itself into being. And yet, there was elegance in this violence, beauty hidden inside brutality, because inflation solved problems that would have doomed the universe before it matured. Without inflation, the cosmos would be curved beyond survival, riddled with defects, uneven and clumpy, unable to form stars. Inflation smoothed the chaos. It erased primordial scars. It delivered a universe that, though born in terror, carried the seeds of harmony, order rising within destruction, symmetry emerging from acceleration. Slowly, though slowly is a word with no meaning here, the runaway expansion began to lose momentum, not by choice but by inevitability. The energy that fueled inflation began to decay, releasing radiation and matter into the newly minted space. The inflaton field relaxed, its tension unwinding. The universe entered a calmer era, one where expansion continued but no longer outraced light. A universe where rules could begin to form, where forces could separate, where time could flow smoothly. The violence softened, though its echoes remained. In its wake, inflation left a cosmos vast beyond comprehension, far larger than anything we will ever observe. Regions separated forever, unreachable, unseeable, abandoned to frost or fire or whatever fates their physics would allow. It created not one universe, but countless cosmic patches, each expanding beyond their own horizons. Some theories even suggest inflation never truly ended, that pockets of space still inflate eternally, spawning countless universes. A cosmic foam where each bubble holds its own laws, its own constants, its own stories. But our story follows only one bubble, our own. The one where inflation eventually slowed, the one where the universe cooled enough for meaning to take root, the one where the impossible violence of those first instants would someday give rise to chemistry, biology, questions, and wonder. It is strange to think that everything we know, every memory, every star, every atom, every breath, owes its existence to a fraction of a second so fleeting it makes the lifetime of a photon seem eternal. Stranger still to realize that inflation treated our universe not as a destination, but as a side effect, a a casualty of reality trying to find stability after the failure of nothingness. Because inflation was not deliberate, it was not planned. It was a cosmic reflex, a burst of expansion triggered by the instability of the void. When nothing broke, space rushed outward, as though trying to escape itself, as though running from the memory of what came before, as though creation was not a choice, but a consequence. And yet in this consequence, the seeds of everything were planted. Even now, billions of years later, inflation's fingerprints remain. The uniform glow of the cosmic microwave background, the distribution of galaxies, the geometry of space-time, the very structure of reality still echoes those first impossible instants. Inflation is not just a chapter in the universe's story. It is the chapter that made all other chapters possible. But within the frenzy, something else began to stir. A quiet emergence hidden beneath the roar. As the expansion slowed, as the field relaxed, as the universe cooled just enough, order began to rise, not fully, not gently, but unmistakably. The chaos would not reign forever. The universe, born in violence, was preparing to calm its breath. Forces would soon separate. Matter would soon form. Simplicity would soon crystallize into complexity. From the frenzy of inflation, the universe prepares to introduce its first rules. In the aftermath of inflation's unimaginable violence, the universe did not fall into peace. It fell into possibility. What had once been a boiling quantum tempest now began, slowly and unevenly, to cool. And cooling is not the end of chaos. It is the beginning of differentiation. As the newborn cosmos expanded and its temperature dropped, the raw, tangled symmetries that once held everything together began to crack. These cracks were not mistakes. They were the first victories of something over nothing, the first signs that the universe would not collapse back into silence. They were the rise of laws, fragile, incomplete, but determined to shape the future. In those early instants, the universe was governed by a single, unified force. No gravity, no electromagnetism, no nuclear interactions, just one indistinguishable field, smooth and symmetrical, holding everything in perfect balance. But perfect balance is a prison. Symmetry can only sustain a static world, a world where nothing changes, nothing forms, nothing evolves. And so, as the universe cooled, that symmetry faltered, it fractured, it broke. And through each fracture, a new rule emerged. The first to separate was gravity. It peeled away from the other forces like a shadow, detaching from the object that cast it. We think of gravity now as gentle, an invisible pull guiding planets and shaping orbits. But in its infancy, gravity was ferocious. It sculpted the curvature of space-time, carving out the fabric that everything else would someday inhabit. With this symmetry breaking, the universe gained structure. A rule had been written into the nothingness. Mass would curve space. Space would tell mass how to move. The cosmos had chosen a direction. It was subtle, but it was decisive. Next came the strong nuclear force, the force so powerful it glues protons together against the repulsive push of their electric charge, a force responsible for the integrity of atomic nuclei, and billions of years later, the fire inside every star. When it emerged, it did so like a scream through the cooling plasma, binding quarks into protons and neutrons. Without it, the universe would be a mist of wandering particles, never gathering into atoms, never forming matter, never giving rise to stars or planets or life. The strong force was another victory over nothing, a declaration that existence would not dissolve into chaos. Soon after, electromagnetism and the weak nuclear force parted ways, a separation born from yet another broken symmetry. Before this division, these two forces were indistinguishable, woven together like strands of the same thread. But as the universe continued to cool, the woven thread unraveled. Electromagnetism took on the role of binding electrons to nuclei, shaping the chemistry of the cosmos. The weak force, subtle and elusive, governed radioactive decay and the delicate alchemy of nuclear reactions. Their separation marked another step away from nothingness and toward complexity. Each of these forces arose not from strength, but from instability. The universe was not designed with rules in mind, it was forced into them. Every law that now seems elegant, every symmetry encoded in mathematics, was born from the universe's imperfections. Symmetry breaking is not a triumph of order over chaos. It is the realization that perfect order cannot sustain a universe capable of becoming anything at all. Perfection must fracture for reality to exist. And so the laws we now revere were not carved into the cosmos like ancient commandments. They were the byproducts of a cooling storm, the aftermath of nothing's collapse, the shadows cast by the universe's own struggle to stabilize. But these laws were fragile. They emerged in a world still on fire, a world where temperature alone determined destiny. A fraction of a degree too hot or too cold, and the forces would merge or break in different ways. The universe would take a different shape. Atoms, if they formed at all, would behave differently. Stars might ignite too easily or fail to ignite at all. Chemistry might collapse into meaninglessness. Life might never find a foothold. The emergence of laws was not a guaranteed victory. It was a precarious balancing act in a cosmos that had only just learned how to breathe. The first particles emerged during this dance of symmetry breaking. Quarks bound together under the strong force, forming protons and neutrons. Electrons danced at a distance, pulled by electromagnetism into patterns that resembled the earliest shadows of atoms. These particles were not yet stable. They flickered in and out, annihilating with their opposites, reappearing in the turbulent energy of the primordial plasma. But slowly, agonizingly slowly on cosmic timescales measured in microseconds, the chaos began to thin. Rates of annihilation fell. More particles survived than perished. Existence was beginning to win its first real battles. Still, the victory was not complete. For every new rule written into the cosmos, nothingness fought back with its own subtler strategies. Quantum fluctuations continued to ripple through space. Uncertainty refused to vanish. Even the laws themselves quivered with potential variations. The universe did not settle into a rigid structure. Instead, it stabilized just enough to avoid collapse, but not enough to lose its flexibility. This flexibility was essential. A universe too rigid would freeze. A universe too chaotic would scatter. But our universe found the narrow corridor between constraint and freedom, a corridor where the laws were strong enough to guide, but weak enough to allow evolution. Gravity began drawing matter into invisible wells of curvature. The strong force ensured that nuclei would endure long enough to create complexity. Electromagnetism orchestrated the first meaningful interactions between charged particles, and the weak force regulated the balance between matter and radiation. Together, these four forces formed the skeleton of reality, the scaffolding upon which all future structures would rise. But their emergence raises an unsettling question. Why these laws? Why this specific arrangement of forces? Why this delicate tuning that allows stars to fuse hydrogen, planets to form, water to exist, life to breathe? If the universe had cooled differently, if symmetry breaking had played out in another sequence, everything would change. Reality itself is built upon the ruins of choices that never happened. The universe did not favor existence because existence was inevitable. It favored existence because instability made nothing impossible to maintain. And so, in the philosophical sense, every physical law is a rebuke to the void. Gravity says emptiness will not remain empty. Electromagnetism says particles will find each other. The strong force says matter will hold together even when repulsion insists it should not. The weak force says transformation is inevitable. These are not just rules, they are victories. Each law represents a moment when the universe, faced with the possibility of fading back into nothing, chose instead the path of persistence. But calling them choices is poetic license. The universe does not decide. It reacts, it settles, it adapts. And in adapting, it reveals patterns that appear deliberate only because they are so profoundly successful. The laws we observe today were not crafted to build stars or galaxies. They are simply the ones that survived the furnace of the early cosmos. They are the ones that worked. Yet within these victories lies a quiet fragility. For though the laws govern everything with astonishing reliability, they are themselves contingent. They depend on the universe's temperature, its expansion rate, its initial conditions. They rely on constants that could have been different and perhaps are different elsewhere if inflation scattered countless regions beyond our horizon. The laws are stable now, but they were born from instability. They carry that memory like a scar. The rise of physical laws marks the moment when the universe finally gained a foothold against the return of nothingness. But the battle was not over. Nothingness does not vanish. It retreats. It hides in the quantum foam that underlies all reality. It lingers in the vacuum energy that pushes galaxies apart. It whispers through uncertainty, reminding existence that it is not absolute. Even so, with each new rule, the cosmos grew more resilient. Structure could form, matter could persist, forces could guide the evolution of complexity. The universe no longer resembled the fractured, chaotic aftermath of inflation. It was beginning to resemble a place where things could happen, not by accident, but by pattern. Atoms would soon emerge, light would soon break free, stars would eventually ignite, but all of that depended on this fragile victory, the birth of laws from the ruins of symmetry. And yet, as the universe settled into the first hints of order, a question lingered at the edges of unfolding reality. A question that would haunt every future epoch of cosmology, physics, and philosophy. But could nothing truly be defeated? Or was it only hiding? For a long time, humans imagined the universe as a cathedral of matter. Stars burning at its pillars, galaxies swirling like stained glass windows, planets drifting like ancient lanterns. But the deeper we look, the more this cathedral begins to vanish. The walls fade, the pillars dissolve, the lanterns dim, and what remains is something far stranger, far emptier, far more powerful than anything we expected. Because the universe is not built on matter, it is carried by nothingness. And that nothingness, paradoxically, is not nothing at all. We call it the vacuum, a word that suggests emptiness, stillness, absence, a void between galaxies, a quiet between particles. But the vacuum is a liar. It is a sea of invisible activity, humming with energies that never rest. Even in the coldest corners of space where matter has vanished and light barely passes, quantum fields ripple beneath the surface like a heartbeat too faint for the senses. At every point in the universe, these fields vibrate with potential. They cannot be turned off. They cannot be silenced. They are the foundation upon which reality stands, even though they appear to be made of nothing at all. Virtual particles flicker in and out of existence, appearing without warning, disappearing without consequence, like sparks from a fire that has no source. They borrow energy from the vacuum itself, live for a moment so brief it cannot be called a moment, and then return what they took. This borrowing and returning is constant, endless. The vacuum seethes with these small, frantic eruptions, yet from a distance it appears perfectly calm. Stillness disguises turmoil. Emptiness hides creation. And so we arrive at one of the deepest paradoxes in physics. The vacuum is the most active substance in the universe, precisely because it is not a substance at all. The things we think of as something, atoms, stars, galaxies, are the exception. The vacuum is the rule. Even the smallest region of empty space contains more energy than every star in the observable universe combined. But this energy is locked away, inaccessible, humming in a register our instruments cannot fully detect. Yet it shapes everything. Gravity bends not only around matter, but around the vacuum's energy itself. Quantum fields dictate how particles behave, how forces operate, how reality fluctuates. Dark energy, the mysterious pressure accelerating the expansion of the universe, is thought to arise from the vacuum too. It is emptiness pushing galaxies apart, nothingness stretching the fabric of the cosmos, the void dictating the universe's fate. This is the vacuum paradox. The more we understand about the universe, the more we realize that nothing still controls everything. After the rise of physical laws, after particles formed and stars began their long march toward ignition, the vacuum did not retreat. It remained the silent architect behind every cosmic structure. It fills every space between atoms, every gap between galaxies, every inch of space where matter does not exist, and even where it does. For matter is not solid, it is mostly empty. Electrons orbit at distances vast compared to their size. Protons hide layers of emptiness within their structure. Everything we touch, everything we see, everything we believe to be solid is nearly all vacuum. Matter is a thin rind floating in an ocean of invisible fields. And yet, this emptiness is not passive. It shapes, it influences, it bends reality toward directions matter alone could never achieve. When particles pass through the vacuum, they interact with fields that determine their mass. When light travels, the vacuum sets its speed. When forces act, they do so because the vacuum provides the stage on which their scripts unfold. Space is not a backdrop. It is an active participant, a quiet ruler that governs the universe without ever appearing to rule. Centuries ago, philosophers believed the void was a simple absence, a canvas waiting for paint. But today we know the canvas paints back. It adds, subtracts, corrects, modifies. Even Einstein's equations include a term for vacuum energy, a term he disliked so much he called it his greatest mistake. Yet it may be the most important term of all, because without the vacuum's push, the universe's expansion would slow. Galaxies would cling too tightly. Gravity would win. But nothingness refuses to let that happen. It drives expansion faster and faster, threatening one day to tear galaxies apart, dissolve clusters, and erase cosmic structure entirely. The universe began with the collapse of nothing, but now nothing is reclaiming the universe, inch by inch, horizon by horizon. As billions of years pass, galaxies drift farther apart, eventually disappearing beyond one another's reach. The night sky will empty. Stars will fade. The universe will grow cold and sparse. And at the end of all things, when matter decays and black holes evaporate, the vacuum will remain, humming with energy, seething with fluctuations, shaping a cosmos devoid of shape. In the long run, emptiness wins. But this victory is not sinister. It is simply the nature of the vacuum, to dominate by existing quietly, invisibly, relentlessly. Matter is loud, stars blaze, galaxies swirl, life thinks. But these are temporary wins, short-lived uprisings against the rule of emptiness. The vacuum is patient. It waits. It knows time better than matter does. It knows how to outlast everything. And yet, despite this cosmic dominance, emptiness is also the reason complexity exists. The vacuum's fluctuations seeded galaxies. Its fields gave particles mass. Its dark energy shapes the fate of the cosmos. Without emptiness, there would be no something. Without the vacuum, existence would collapse. Nothing sustains everything. The more we study this paradox, the more philosophical it becomes. If the vacuum is not empty, what is it? A field, a foam, a fluctuating fabric, a physical entity, a stage for existence, or the main actor? Even physicists cannot fully describe it. Our best theories give hints, equations that whisper instead of shout. But these whispers lead to profound realizations. The vacuum is not a void, but a reservoir of hidden truth, a place where the rules of nature originate, a background that is not background at all, but the very heart of reality. Perhaps the most shocking truth is this: most of the universe is vacuum. Not matter, not radiation, not galaxies. Empty space makes up almost everything. And yet this emptiness is the most powerful force we know. It sets the boundaries of what we can see. It dictates the expansion of the cosmos. It influences every particle, every field, every moment of existence. Matter is the decoration. Vacuum is the foundation. But this leads us into existential territory. If emptiness governs reality, then what does that make the things we call real? Are galaxies the exception in a universe ruled by nothing? Are we little islands of matter floating in an endless ocean of invisible energy? Does the vacuum itself hold the deeper truth of existence? A truth older than matter, older than stars, older than time? In the earliest moments of the universe, nothing collapsed. Then nothing accelerated. Now nothing expands the cosmos. And one day, perhaps nothing will dictate the final fate of everything. The vacuum reveals a universe where emptiness is not weakness, but strength. Not absence, but influence. Not silence, but motion. Nothingness is not the dead state we once imagined. It is the quiet engine powering the cosmos. When we stand beneath the night sky, looking at the stars, we imagine we are seeing the universe. But what we are truly seeing is the exception. The night sky is mostly dark, mostly empty, mostly vacuum, and yet that vacuum is alive with fields and energies more powerful than any star. If nothing fills the universe, what does that make everything we know? For billions of years, the universe sculpted grand structures from its own cooling breath, stars igniting, galaxies spiraling, planets forming from dust and collision. But for most of cosmic history, these structures were silent. Beautiful, yes, radiant, certainly, but silent. No star knew it was burning. No galaxy knew it was turning. No atom knew it was dancing in the dark. The universe was magnificent yet unaware, vast yet voiceless. And then, in a tiny corner of an unremarkable galaxy, something astonishing happened. Against the immense pressure of entropy, the law that drives everything toward dispersal, disorder, forgetting, a fragile spark of resistance flickered into being. Life began. It began quietly, as all rebellions do. Molecular patterns that copied themselves, chemical loops that fed on gradients, tiny systems carving out islands of order in the ocean of cosmic decay. These early forms were not destined, not designed. They were improbable arrangements of matter defying the universe's natural slide back into nothingness. Life was the first phenomenon to say, not yet to stillness, not yet to dissolution, not yet to the void that waits patiently for all things. Life was organized defiance. As these fragile systems evolved, they discovered new ways to resist entropy. They built membranes to protect themselves from chaos. They harvested energy, converting light or chemicals into motion. They reproduced, outpacing decay with creation. Life was not simply a property of matter. It was matter learning to fight. And slowly, almost imperceptibly, this fight grew more elaborate. Cells cooperated. Multicellular beings emerged. Nervous systems appeared, tiny sparks of coordinated response. Creatures learned to sense their surroundings, react to danger, seek opportunity. The universe was no longer silent. Patterns became behavior. Behavior became purpose. And then, one day, purpose became thought. Consciousness, that fragile miracle, that flicker of awareness in a universe that had been blind for billions of years, arose like a flame that did not know it could burn. Suddenly the cosmos could reflect upon itself. A small cluster of neurons inside a small creature on a small planet became the first mirror the universe had ever held up to its own face. For the first time, existence knew it existed. Life had become more than resistance. It had become understanding. This was the most improbable moment in cosmic history. The laws of thermodynamics do not favor thought. Entropy does not encourage memory. The vacuum does not nurture awareness. And yet here it was, a mind capable of asking questions, a mind capable of fearing its own disappearance, a mind capable of love, grief, hope, longing, a mind capable of wondering why anything exists at all. If matter is the universe's structure, consciousness is its voice. But this voice is fragile. Every thought is an arrangement of atoms. Every memory is a pattern that must be maintained against the constant pressure of disorder. The brain is a temporary victory over nothing, a collaboration of cells that rewrites itself every moment while decay whispers at its edges. The fact that any creature can think, dream, remember, imagine is astonishing. We are improbable survivors of an ancient battle we barely understand. Life, from its first spark to its most complex forms, fights a war on two fronts. On one side is entropy, the inevitable slide toward disorder. On the other is time, the quiet eroder that pulls everything back into stillness. And yet for a sliver of cosmic duration, life holds its ground. A single heartbeat defying the silence, a single breath pushing back against infinity. Every organism that has ever lived, from bacteria to blue whales, from moss to human beings, participates in this resistance. We are continuations of an unbroken chain that stretches back nearly 4 billion years. Each link in that chain survived long enough to reproduce, to fight back entropy with structure, order, and persistence. Life is not guaranteed. It is not common. It is a phenomenon that should not exist yet does, a rebellion carved from stardust. Human consciousness adds a new twist to this ancient struggle. We not only resist nothingness physically by living, growing, reproducing, but psychologically. We imagine futures, we mourn losses, we create beauty, we crave meaning. Meaning is not written into the laws of physics, it is written into the human heart as a response to the void. When we create stories, art, science, love, we are doing more than passing time. We are building bridges over the abyss. We are saying, my existence matters, even though the universe never asked that question. And yet, in quiet moments, we feel the pull of nothingness, the fear of death, the fragility of memory, the strange realization that consciousness is temporary. Everything we know, every face, every joy, every heartbreak, is carved in sand beside an incoming tide. This awareness does not defeat life, it deepens it. The fragility of existence gives weight to each experience. A sunset is beautiful because it ends. A life is meaningful because it is brief. Even love is illuminated by the shadow of loss. The universe that created us is ancient, cold, and indifferent. Yet life responds with warmth, connection, purpose. Against the emptiness of space, we build relationships. Against the silence of the void, we speak and sing. Against the inevitability of entropy, we create families, memories, legacies. Every act of kindness, every spark of creativity, every question we dare to ask is a momentary triumph over the nothingness that surrounds us. This does not make us separate from the universe. It makes us expressions of it. The cosmos evolved life to resist its own decay, consciousness to reflect upon its own origin, curiosity to probe its own mysteries. We are not passengers, we are participants. Our existence is the universe discovering new ways to organize itself, new ways to hold off oblivion for as long as possible. Yet even in this triumph, we cannot escape a difficult truth. The battle is temporary. Entropy always wins in the long run. Stars will die. Galaxies will fade. Black holes will evaporate. Memory itself will dissolve. The vacuum will outlast everything. And life, no matter how fiercely it resists, must someday surrender to the tide of unmaking. But this inevitability does not diminish life's significance. It enhances it. Fragile things shine brighter. Temporary moments carry more weight. Consciousness gains meaning precisely because it is rare, delicate, and fleeting. Life is the universe's brief rebellion against the final quiet. For a time, a cosmic instant, the void retreats. For a time, entropy is held at bay. For a time, the universe knows itself through us. We are not the center of creation. We are its question. We are its echo. We are its temporary flame flickering against eternal dark. And though the flame will fade, the fact that it ever burned at all is a miracle of cosmic defiance. There is a strange comfort in this perspective. Life does not need to defeat nothingness to matter. It simply needs to exist long enough to feel the wonder of being here, to look up at the night sky and sense its own smallness, to love despite loss, to hope despite uncertainty, to ask questions that have no answers. These acts are not failures. They are triumphs. They are the universe refusing to accept silence without first singing. And so we live, knowing the outcome but choosing resistance anyway. Every heartbeat a quiet protest, every thought a reminder that nothing has not won yet. Every life a brief, beautiful argument against oblivion. But even the most persistent flame must dim. Even the brightest consciousness must one day fall quiet. Even life, bold, defiant, miraculous life, cannot hold the void forever. But even life must one day surrender. Billions of years pass and the universe enters a long, slow twilight. The once vibrant cosmos that burned with the light of trillions of stars nigh grows thin and dim like a lantern running out of fuel. The great spiraling galaxies loosen their grips, their arms unraveling as gravity weakens across expanding space. Stars that once forged the elements of life burn through their nuclear fire and collapse into embers. White dwarfs fading to black dwarfs, neutron stars cooling into silence, black holes waiting for their long, lonely evaporation. The night sky, once bright with possibility, becomes sparse. Darkness spreads between the remaining points of light until even those points begin to vanish. The universe is aging, not in years, but in entropy, a steady drift toward disorder that no force can resist forever. Heat spreads until there are no gradients left to drive motion, no differences left to create structure, no energy left to spark new stars or ignite fresh beginnings. Every galaxy that now drifts beyond our cosmic horizon becomes unreachable, then unseeable, then absent from our sky in every meaningful way. Not because they disappear, but because space itself expands faster than light can carry their last messages to us. The universe becomes a graveyard of light, scattered too far apart to matter. Yet the fading is quiet. There is no great collapse, no final explosion, no cosmic funeral pyre. Instead, there is a kind of cosmological exhale, a slow release of everything the universe has carried for so long. Particles decay, motion slows, vibrations stop. The temperature of the cosmos approaches absolute zero so gradually it feels like the universe has forgotten what warmth ever meant. The stars have gone out. The galaxies have dissolved. Even black holes, the last titans of structure, evaporate over unimaginable timescales through Hawking radiation, shrinking into nothingness like shadows dwindling at the end of day. Eventually, all that remains are the faintest traces of energy scattered thinly across a volume of space so vast that the word emptiness feels inadequate. The universe slides toward heat death not with violence, but with surrender. The silence becomes deeper than any silence that has ever existed. And still it deepens more. This is the return of nothing. Not the nothing of primordial chaos, but the nothing of exhaustion. A universe that has spent all its energy, used all its options, stretched its potential across trillions of years until nothing remains except possibility without form. The cosmic stage clears itself. The actors fade, the lights dim, and what remains is almost exactly what preceded creation, an endless, shapeless, silent expanse. But this raises a haunting question. Is this truly an end? Or is it a return to the beginning behind all beginnings, even in the far future, even in near-perfect stillness? Quantum fields do not fully quiet. The vacuum still seethes with faint fluctuations. Energy cannot be entirely extinguished. It hides within the mathematics of the vacuum itself, waiting for the right instability. The same paradox that ignited the universe billions of years before may still linger in this future void. Absolute nothingness may once again fail to hold its shape. Instability might creep in. A new inflation might erupt from the ashes of the old. A new universe, or many, might stretch outward from a single quantum tremble. Perhaps the universe is not a single story, but a series of acts. Perhaps nothing is not the final chapter, but the quiet turning of a cosmic page. If the laws that broke symmetry once can do so again, if the vacuum that birthed stars can collapse into new possibilities, then heat death may not be a tomb, but a cradle, a place from which new worlds emerge, unaware of the ashes beneath them. And so we imagine the cycle: light, darkness, possibility, let's see, light again, a sequence without beginning or end, carried by the heartbeat of nothingness itself. The universe dies into silence, only to rise again through a spark that defies understanding. Existence flickers in and out like a breath drawn by something far larger, far stranger, far more patient than time. But even if no new universe forms, even if this heat death remains final, the ending retains a profound beauty, for the universe has returned to the state from which it came, not violently, not tragically, but gracefully. After all the stars, all the galaxies, all the moments of life and thought and wonder, the cosmos sinks back into stillness, not because it failed, but because it completed its arc. When everything ends, nothing remains. But from nothing, everything once began. The story returns to where it started, the paradox of nothing. At first, nothing seemed like weakness, an absence, a void, a lack of power. But across the universe's long journey, nothing proves to be the most enduring force of all. It is the stage upon which existence performs for a brief, astonishing moment. It is the silent partner in every law, every star, every life. It is the background that remains when all foregrounds fade. Nothing does not demand attention. It does not fight or build or destroy. Instead, it waits, calm, patient, unchanging, until the universe exhausts itself. It is the place where meaning dissolves, but also the place where possibility gathers. We return to nothing, not as punishment, but as a return to origin. The mystery that birthed existence is the same mystery that receives it at the end. It is strange, almost comforting, to realize that nothing holds us twice, once before we are born, and once after we vanish. Everything in between is a temporary rebellion against the silence, a brief illumination in an ancient dark, a moment when the universe through us opens its eyes and wonders. Perhaps the power of nothing is not in what it removes, but in what it allows. Without nothing, there could be no beginning. Without nothing, no laws could arise, no stars could burn, no life could dream. Nothing is not the opposite of existence. It is the canvas that makes existence possible. And so the story ends not with certainty, but with calm acceptance. Nothing is not the absence of power, but the origin